So we've looked at how to create the confidence interval for proportions as well as means. This time we're going to look at how to figure out how many people or how many things you need in your sample in order to get the accuracy that you want, just like we did with the means earlier. So remember, the effects of changes to certain aspects of the interval will have on the margin of error. If we have more people in our sample, we get more accuracy, so we have a narrower interval. If we have higher confidence, we have to have a wider interval. So we know that the confidence level and the size of the sample have an effect on the margin of error. As we discussed before, we really don't have control over the level of confidence. That's sort of determined by the context of the situation. So really what we need to do is figure out how large a sample we need in order to get what we want. And there's a real simple formula for it. Well, I say it's real simple. It's actually not as simple as it was for the mean, I don't think. The number of people we need in our sample is P times Q times the fraction, our z-score associated with the confidence level, divided by the margin of error that we want, and that's going to be as a decimal, and we need to square that. And if we have no idea what value P is going to be, sometimes we will, because we've done this same study before last year or something like that. Sometimes we have no idea, so we use the actual worst case scenario, which would be 0.5. If the population's 50-50, then we need a bigger sample than we do if it's 10% or 30% or something like that. So let's do a couple. We think that 2/3 of the population will prefer chocolate ice cream. We want a 95% confidence level, and we want a margin of error of 5%. So how many people will we need to study in order to get those results? Well, 2/3 is 0.67. 1 minus that for Q would give us 0.33. The z-score associated with 95% is 1.96. And the margin of error we want is 5% as a decimal. So not 5, but 0.05. And we need to square that. Definitely calculator work. So 0.67 times 0.33, open parentheses. And then we can put in, let me get that visible there, our 1.96 divided by 0.05, close parentheses, and square that quantity. And that'll give us 339.75. And you always want to round this up because 339 would be too few. So it'll be 340 that we'll need in our sample in order to get the confidence level and the margin of error that we want. Okay, let's do one more. Suppose we'd like to know what percent of people prefer anchovies on their pizza. We want 99% confidence level, and we want a 1% margin of error. And we have no clue what the proportion actually is going to be. I think I actually do have a clue that it will be fairly small, but for the sake of argument, let's not. So how many people are we going to need? Well, worst case scenario would be 0.5 for P, which would also be 0.5 for Q. And that's going to be 2.58. I'm sorry, I don't have those numbers in front of me at the moment. I think it's 2.58 divided by 0.01 squared. So we have 0.5 times 0.5 times, in parentheses, 1.96 divided by 0.01 squared. 9,604. That's kind of amazing that we would need that many, but we do, because we want a very small margin of error, right, 1%, and we want a high confidence. And notice where those numbers go. The confidence level is this number here. The higher the confidence level, the bigger this number is going to be, and that's going to make this result bigger. The narrower the margin of error is, the smaller it is, we're dividing by that. Dividing by a very small number also makes this tend to be bigger. So you can see how the margin of error and the confidence level affect this. They affect it actually a lot more than the actual percentage do. So let me give you one. I think that 90% of Jefferson County residents are connected to Jeffco in one way or another. I want a 90% confidence level, and I want a margin of error of 2.5%, so 0.025. Go ahead and pause it and see what you get for this result. You should get 387.3, which you would round up to 388. 387 is not quite enough. Your margin of error will be a tiny bit bigger than you're after. All right. I think we've got 2 more to go before the end of this. I'll talk to you next time.